Hi one and all, and welcome to today's video on measures of spread in brackets extending. Again, this extending stuff means it's taking it that little bit further along, and it is so good to see you. If you are new, welcome. If you are not new, welcome. Lovely to see you. I am MaffsGuru, otherwise known as Darren, and this video is an exciting travelation along the ideas of measure of spread. It's dealing with data representation and interpretation. Really hard for me to say. Yes, did just smack my face. Ouch, that really hurt. But the idea is we're here looking at what do we call spread. Now, in the previous video, we've looked at range. Actually, that's not a great measure of spread. We know it's easy to find because it's the biggest number, take away the smallest number, but it actually has a huge problem. But I'm going to hold that for this moment in time because I've said, if you are new, it is lovely seeing you. I am a small person trying to do an actually pretty large job. And if you could help me by subscribing, by clicking that red arrow, I would be deeply, deeply grateful. Lovely, lovely, lovely if you could also tell your friends. I just want people to know that these videos are there to try and assist. Now, by the end of this lesson, I obviously want you to know what it means by spread of data, and you can probably already see some pictures beginning to appear below at the bottom of the screen. I want you to know how to find the range. I want you to know why range isn't a good measure of spread, what it means by the interquartile range. Now, I want you to think about that. Think about the language. Interquartile range. What does the word inter mean? What does the word quartile mean? And what does the word range mean? Can you use the English to try and work out, before I even get there, what it actually is? Now, in a previous lesson, or lots of previous lessons, we have dealt with the mean, the modian, the modian? No, that's imodium. That's something completely different. It's a bit of funny tummy. But we'll try that one again. Mean, median, mode, and of course, range. Yes, and those things we believed to be called summary statistics. Now, you may not know that they're called summary statistics, but now you do. All right, Barry, as usual, calls these things all sorts of random names to try and confuse you. And so hashtag no more Barry. Thank you very much. The one we're dealing with at the moment is not the measures of center. They're one subset of the summary statistics. The range we're looking at is the measure of spread. Now, I don't know about you, but I'm over here in Australia, and we have this stuff called Vegemite, which, if you're in the United Kingdom, is very much like Marmite. Actually, it's nothing like Marmite. They are both revolting, and just the idea now makes me want to be... Now, I don't know about you, but if I'm looking at spread, what type of spreader are you when you make toast? Are you one of those that pushes it right to the corner because you want every last millimetre of that toast covered? Or do you just puddle it in the middle and sort of leave it there? Me, if it's Vegemite, I literally just tap it to the centre and then spit it out because I don't want it. Thoughts on Vegemite? You either love it or loathe it. It'd be fascinating to see how many people love it. And I'm pretty sure that my comment section will be empty because no one loves Vegemite. And if you do, you want to get your taste buds centered. Now, in mathematics, we have this measure of spread because we want to see how far spread the data is. Now, what I'm saying by that is, if I knew I had some data, I'm going to draw sort of a bit of a picture, and I knew that the data was spread out like that, well, it doesn't really say very much to me. It seems fairly spread out. I don't know. If I draw something below it that then has the data like this, which do you think is the most spread out? The diagram at the top or the diagram at the bottom? Well, obviously the diagram at the top is the most spread out, and the one below it is itty-bitty, yes? And so sometimes drawing these diagrams helps us compare data to see which is the most spread out. Now, we've been dealing with the range before, and here are some examples taken from the Cambridge Essentials textbook series. Thank you, Cambridge, for allowing me to use your examples. Much respect, greatly appreciated. Hopefully, I'm doing you guys proud. But it says, find the range of the following sets of data. So, nice and easy. Remember, because we don't want to be tricked, we're going to put the numbers in order first. So we'll deal with part A, and we have 1, and 2, and 3, and 4, and 5, and 8, and 12. Now, have I got all the data items? Who knows? I'm going to go and check. So I've got 1, 2, 3, 4, 5, 6, 7 pieces of information there. 1, 2, 3, 4, 5, 6, 7 pieces of information there. They're in order. And so what can I do to find the range? Well, nice and easily, the range is the biggest number, which is 12, minus the smallest number, which is 1. And that gives me 11. So I now know that there are 11 numbers between, or there's 11, yeah, there's 11 numbers between my highest number and my lowest number. That's a measure of spread. What about part B? Ooh, evil Barry. They've thrown in negative numbers. Yuck. That's okay. We know where negative numbers fit on a line. So we're going to have that first one as minus 24, minus 20, minus 6, 7, 12, and 19. Again, let's just check. 1, 2, 3, 4, 5, 6 pieces of information. 1, 2, 3, 4, 5, 6 pieces of information. And ladies and gentlemen, what is my range? Well, it is the difference between the highest number, which is 19, subtract the lowest number, which is minus 24. Now again, depending on how good you are at maths and negative numbers, you've probably noticed there that we have a minus and a minus together. And when we have a minus and a minus together, it becomes a plus. So that's actually the difference between 19 plus 24, which gives me a range of 43. Now, what do we notice there? Much, much bigger range of numbers. Huge range. There are 43 numbers between the first number and the last number, whereas in part A, we only had 11. Now, if you're not sure how that minus thing works, let's think of actual temperature. If we had a temperature scale, 19 is at the top there because it's actually quite toasty. Where would minus 24 be? Probably down there somewhere. Now, if you're in Australia, you don't deal with negative temperatures quite like the rest of the world does, like the United Kingdom, Canada, America, all sorts of different places. But what I want to say to you is now, what is the difference? How many numbers are there between 0 and 19? There are 19 numbers. And how many numbers are there between 0 and minus 24? Well, if I'm going 24 floors down, one would hope there are 24 numbers. And so what is the difference between the biggest number and the smallest number? Well, if I do 19 plus 24, I get 43. So that's actually just another way of thinking about it. So finding the range is really, really basic, but we have problems with outliers. Imagine I come up and I'm on the street and I'm sort of surveying people and I'm saying, hi, can you tell me your age, please? And they go, yeah, I'm 63, I'm 42, I'm 18, I'm 19, I don't know, 27, I'm 38, I'm 62. And then somebody goes, too busy for this, I'm actually minus 6. Well, that's not very nice for a start, but sadly, because it's a survey and a video's coming up on this later, you can't turn around and go, mate, nah, not right. You can't tell me minus 6, that's not your age, because you have to believe what they say. So if I now look at my data, I have minus 6, and my next data value is 18, 19. Let's see if I can put these in order. Minus 6, 18, 19. What would next be? 27, 38, 42, 62, and 63. Now, if I'm going to look at my range now, my range would actually be, with that data, the difference between 63 and minus 6. So that would be 69. But that's actually not true. That doesn't make any sense. It's a lie. Because really, our range should have been probably somewhere between 18 and 63. This value here, this outlier, has made my range useless. So if we can, we're going to try and find an area of mathematics where the range is actually a better measure of spread without using an outlier. Now, generally speaking, ladies and gentlemen, let's draw this slightly better. We can split data into quarters. Imagine I have some sort of information, some sort of graph. Well, we know that this value here is the median. We know this value here is the lowest. That value there is the highest. And we can actually split the graph again into what we call quartiles. Now, you may have heard me say quarters, and that's very, very close. Quartiles. So there's actually 1/4 of the data here, 1/4 of the data here, 1/4 of the data here, and 1/4 of the data here. It's like slicing a cake, just a very large cake. Yes? Well, if I think of this in terms of percentages, that's 25% there, there's 25% there, 25% there, and 25% there. And lo and behold, ladies and gentlemen, we can actually create an area of mathematics where we actually just look at the middle 50% of our data. We look for the upper quarter, the lower quarter, and we look at the range between those two, because that means then any outliers at the end of my data can be ignored. Yeah? Now, there's another way we can do this actually by using something called a box plot. Okay? And box plots are absolutely awesome. And I'll come back to what they are now, and then we'll look at how we use them. Believe it or not, a box plot is literally a box drawn like that. That is a box plot, but it stands for something really freakily awesome. This little line here stands for what I call my lowest value. This one here, nah, is not. This one here is called my highest value. Now actually, the problem with this is I'm rushing a bit too far, because the reason we've drawn these circles is because they're actually outliers. So what I'm going to do is I'm going to say to you, for this moment in time, we're going to ignore them, and I'm going to draw my little box plot like that. Now you're going to say, hold on a moment, doesn't it have to be symmetrical? Doesn't that little line have to be the same as the big line? Absolutely not, and we'll come more to that at another point. What's this value here? Well, it seems to be in the middle of the data, so it's called the median. And what's this value here? Well, because we seem to be splitting this into quarter, there's a quarter, there's a quarter, there's a quarter, and there's a quarter. This line here stands for something called the upper quartile. And so, what do you reckon that line there stands for? It is the lower quartile, and I'm running out of space to write. Okay, so we have something called the upper quartile and the lower quartile, and I think my hands are the wrong way around there, so let's try and work that one through. So the upper quartile is here and the lower quartile is there, because I've got to reverse things for the camera. That's actually what we're then going to do with some numbers. So you're trying to find, with any set of data, the median, upper quartile, lower quartile, and then we're going to do something with those two quartiles. And obviously the best way to do something is with an example, he says, trying to move this around. Right, so we've got some data here, 1, 5, 8, 2, 13, 10, 4, and 14. Now the first thing we ought to do, remember, with all of this is write it in order. So we have the number 1, 2, what's the next one? Let's just start crossing these off so I get confused. 4, 8, 4, 8, 10, 13, 14, and 15. So let's just check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces of data there. Now, changing my color, because it makes it really, really helpful. Remember, what were the rules to help us do this? Well, if we scroll back up, and I'm not going to, the first rule said, put them in order. The next one says, find the median. And we know how to find the median. We cross off ends until we get to the middle. Now, if I do that, and I'm not going to do that at the moment, but the 1 and the 15 match, the 2 and the 14 match, the 4 and the 13 match, and actually my median sits between 8 and 10. Well, we know what's halfway between 8 and 10, so I now know my median is equal to 9. Is that important to me? Well, actually no, believe it or not, the reason we know the middle point is because, like when we have a cake, how do I cut a cake into quarters? Well, generally speaking, we slice it in half, and then we slice the halves in half. So that's what I'm going to do now. I've got half of my data here and half of my data here. So like my cake, I'm going to cut the halves into halves by crossing off again. So 1 and 8 and 2 and 4. So again, my lower quartile sits between 2 and 4. So that value is 3. And we now know that this thing here is called the lower quartile. Now we'll do it to the top half of my cake. So 10 and 15, 13 and 14. So we know my middle value now lies between 13 and 14, and that's 13.5. And we know that that is my upper quartile. How do we find the interquartile range? Now, if you go back to the beginning, I said, do you know the language that helps us with this? Interquartile range. Well, the interquartiles are the lower and the upper quartiles, and it then says range. How do you find the range? The bigger one minus the smaller one. So our interquartile range, our IQR, because we like to abbreviate things, don't we, Barry? IQR is equal to the upper quartile, which is 13.5. Subtract the lower quartile, which is 3, which gives us 10.5. Now again, the reason we're doing this is we've looked at the middle 50% of the data. Yes, we've looked at that middle half of my data to get rid of those outliers. And what we're saying is that the spread of the middle 50% is 10.5. And as long as we do that with all of my data, then my comparison won't be affected by my outliers. Let's do the next example. What have we got here? Are they in order? No. So we've got the numbers 2, 3. Let's keep crossing them through so I don't make a mistake. 4. What's then? 5, 6, 7. We've got 7. How many 8s have we got? 1, 2, 3 8s. 8, 8, 8. Oh, Mr. 6. Oh, that's annoying. So 6, 7, 8, 8, 8. 6, 7, 8, 8, 8, and then 9, 10, and 11. 9, 10, and 11. Let's just check we've got the right number of data items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Thank you very much. They are now in order. So what is the next step we do? We cut our cake in half. I thank you. So changing color again. Let's do that by crossing off the ends. Again, I'm not going to cross them off. So 2 and 11, 3 and 10, 4 and 9, 6 and 8, 7 and 8. And ladies and gentlemen, we have a beautiful number in the center. So we now know that's my medium. What do we now do? Well, we ignore that middle number now because we've cut the cake in half. That's the halfway point. And now we look either side of that for my new halves to cut them again. Remember, we're cutting our cakes into 4 pieces. We've done the middle cut. Now we cut the halves as well. So 2 and 7, 3 and 6, and 4. I thank you very much. So this is now my lower quartile. And I'm going to use LQ to help me. And 8 and 11, 8 and 10, and 9. And there, ladies and gentlemen, is my upper quartile. So do I have all the information I need for my interquartile range? Well, I should think so, because my interquartile range now becomes the upper quartile minus the lower quarter, that bigger quarter minus the lower quarter, because that's 50% of my data. That gives me 9 minus 4, which gives me 5. And so there are 5 numbers gap between my middle 50% of the data there, and there were 10.5 numbers gap on my A. And we could say that part B was closer together. The data was squished closer together. This stuff is absolutely amazing, all right? And as I say here, almost at the end of the lesson, the interquartile range is looking at how we spread the data out, but in this situation, for the middle 50%. One last thing I want to say, because Barry once again tries to trick us. Sometimes you may see that the lower quartile is expressed as Q with a little subscript 1, and the upper quartile is actually Q3. Don't worry too much about that, just learn it, because again, maths is trying to trick you. We'll come back to more of that in a slightly later video, but it has been good actually doing this. Hopefully you now understand what it means to have a range. Range is bad because of outliers. Spread, Vegemite, yuck. Interquartile range, looking at the middle 50%. Thank you so much for watching. It's been really good seeing you. Okay, it's the end of the video. You get to almost go now, unless you haven't subscribed. And over there, ladies and gentlemen, is a doohickey that will let you subscribe. And loading just below it is a video from this series that may also be useful. It's been good seeing you. Thank you so much for coming along. I hope you've enjoyed it. I look forward to seeing you next time. Take care. MaffsGuru, out.